Find the second derivative y double prime or d squared y dx squared for the function y equals the square root of 3x squared plus 4. Then evaluate y double prime of 2. So y here is the square root of an entire expression, 3x squared plus 4. Before we take the derivative, let's rewrite the square root as first power second root, so we will have 3x squared plus 4 to the 1/2 power. Our first derivative, y prime or dy dx, will be found by starting with the power, bring it down, leave the inside alone, 3x squared plus 4, subtract 1 from the power, I will call that 2/2, and now multiply by the derivative of the inside to complete the chain rule. Now the constants can be brought together, so we have a 1/2 and a 6. 1/2 times 6 is 6/2 or 3. So I have a 3. I also have this x here. And I will have the 3x squared plus 4 to the 1 minus 2 negative 1/2 power. We need to take the second derivative, the derivative of this. One option is to leave it the way it is, and it's therefore a product rule. Another option is to move the negative exponent to the denominator to call it a positive exponent, and then use the quotient rule. I'm going to keep it the way it is and use the product rule. Either version will work. But since it's already sitting as a product, I will just keep it that way. So our second derivative, y double prime or d squared y dx squared, is, as a product rule, derivative of the first. The first is at 3x. Derivative of that's a 3 times the second left alone, so 3x squared plus 4 to the negative 1/2. And then add to it the first left alone, 3x, and then the derivative of the second. Bring the power down to negative 1/2. Leave its inside alone, 3x squared plus 4. Subtract 1 from the power, I will call that 2/2, and then multiply by the derivative of the inside to complete the chain rule, 6x. So my second derivative, y double prime or d squared y dx squared, will be the first term I'm going to leave alone, 3 times 3x squared plus 4 to the negative 1/2. The second term, I have several constants I'm going to put together. I have a 3, I have a negative 1/2, and I have a 6. 3 times 6 is 18. If you multiply that by negative 1/2, you'll have negative 18/2, or negative 9. So I have a minus 9. I have an x here, and I have an x here. So that will be x squared. And then I have a 3x squared plus 4 to the minus 1 minus 2 minus 3/2. Now one option here is to move those negative exponents to the denominator and then find a common denominator. Another option is to factor. And since I already have them in the numerator, I'm just going to factor this now. Either way will work. There's a 3 that will factor out, and we can start with that. So just write the result after factoring just the 3 out. If I factor the 3, that's going to take away this 3 and make a 1. It'll take away that and leave a 3. So there's what we should have left. So 3 times the 3x squared plus 4 to the negative 1/2, and then minus 3x squared times a 3x squared plus 4 to the negative 3/2. In my next step, I'm going to factor a little further by factoring out the power of 3x squared plus 4. In each term we have a 3x squared plus 4. We have it in the first term to the negative 1/2 power, and the second term to the negative 3/2 power. We can factor out the lower of the two, and that will be the negative 3/2. It's more negative. So we will have a 3 times 3x squared plus 4 to the negative 3/2 power. Factored out. Now when you factor, you're dividing, and dividing means subtracting exponents. So we're going to be subtracting a negative 3/2 from each of the exponents that were originally in there. Subtracting a negative 3/2 is equivalent to adding a 3/2. And so what we're going to end up doing is adding a 3/2 to this. Well, negative 1/2 plus 3/2 is 2/2 are just 1, so that is going to become a power of 1. And negative 3/2 plus 3/2, that'll become a power of 0, and anything raised to 0 is a 1. That's because we just factored that out, so all that's gone. So there's what we should have left. 3x squared plus 4 to the first power, and then minus 3x squared. Well, we have our first part of the expression, 3 times 3x squared plus 4 to the negative 3/2. I'll leave that all the way it is. And inside the square brackets, we can remove the parentheses. We will have 3x squared plus 4 and then minus 3x squared. And those 3x squareds can cancel. And we're left with a 4. And that 4 can move out the front with the 3 and give us a 12. So we have 12 times 3x squared plus 4 to the negative 3/2. At this point, we can move that negative exponent to the denominator and call it a positive exponent. And we will have 12 divided by 3x squared plus 4 to the positive 3/2. All right, there's a simplified version of the second derivative, y double prime, or d squared y dx squared. The next thing to do is evaluate y double prime of 2, which means to plug a 2 in for each of the x's. So we will have 12 divided by 3 times 2 squared plus 4 to the 3/2. So we have 12 divided by 2 squared is a 4, so 3 times 4 plus 4 to the 3/2. And that will be 12 divided by 3 times 4 is a 12 plus a 4 to the 3/2. So 12 divided by 12 plus 4 is a 16 to the 3/2. Now the 3/2 power means to take the square root of the 16 and then cube that result. Square root of 16 is a 4, and we will have 4 cubed. Now instead of raising 4 to the 3 power, I'm going to simplify by taking one of the 4's out of here and one of the 4's out of the numerator. And so I will have 3 over 4 squared, or 3 over 16.